Okay, here's a video for Chapter 7 test. First of all, we're supposed to get the exact value of this. So we want to know where the cosine is negative 2 over the square root of 3. Well, negative 2 divided by the square root of 3, square root of 3 is smaller than 2, so this would be, this part would be greater than 1, and since it's negative, it's less than negative 1, and so this is not possible because cosine is always between 1 and negative 1. Number 2, when's the cotangent? Negative 1 over the square root of 3. So this is cotangent, so we got to pick something in the first and second quadrants because that's where we take capital cotangent from. So if the cotangent is negative 1 over the square root of 3, then the tangent is square root of 3 over 1 and negative. And the angle that has that, the sine would have to be long and the cosine short. That's square root of 3 over 2 over 1 over 2. And so we're going to have to do this one where the tangent's this in this quadrant because that's where cotangent is negative. So if I want the sine to be long and the cosine to be short, it would have to be there with the cosine being negative half. And that angle, because it's asking for the angle where the cotangent is at, and that would be at 2 pi over 3, 120 degrees or 2 pi over 3 radians. And I asked for everything in radians. The next one, if the secant is 2, that means the secant is 1 over the cosine. So the cosine inverse is going to have to be 1/2. Because if the secant ratio is 2 to 1, the cosine ratio is 1 to 2. And we take the cosine out of the first and second quadrants, and it's 1/2 in the first quadrant at pi over 3. 3 says write an expression for u containing u for this. This says there's an angle where the sine is u over 1. So I'm going to make an angle, and sine is y over r, or opposite over hypotenuse. So this is the angle that's going to have a sine of u to 1. I need to know this side. So we got x squared plus u squared equals 1 squared. So x squared equals 1 minus u squared. So x is equal to the square root of 1 minus u squared. Square root of 1 minus u squared. And now we got to find the cosine of the angle. The cosine is x over r, or adjacent over hypotenuse, so that's going to be the square root of 1 minus u squared over 1. Okay. Now let's do 2a. Determine the exact value and in radians where appropriate. This says there's an angle where the sine is 0.9. So I'm looking in the unit circle. The y-coordinate is 0.9, which could be here or there. But capital Sine says do it in this quadrant. And now it says find the sine of that angle. Well, the sine is 0.9. This says here's an angle of negative 7/8 pi. So I got to go this way 7/8. So that'd be 1, 2, 3, 4, 5, 6, 7 eighths. 7 out of the 8. So there's the angle. It says look at the cosine on that one. So if I draw it to the x-axis, the cosine's the long side. And now it says find an angle in the first or second quadrant that has the same cosine value. Well, that's cosine is negative. So to keep it negative, I'd have to just go up here, and that's the only place in here where the cosine would be that long and negative. And if this was 7/8, this was 1/8 pi over 8. This is pi over 8, so this would be plus 7/8. So it's 7 pi over 8. Another way you could look at this particular one, the cosine doesn't care whether it's positive or negative, and you could have gone this way and then said, where's the cosine? That value, and it would have been 7 pi over 8. This one says, find an angle where the sine is negative 1/2, and it's in capital sine, so the sine is in the first and second, and it's negative down first and fourth, and sine is negative down here, negative 1/2. And the cosine would be this long side, and it'll be positive square root of 3 over 2. And now we've got the tangent is 3/2. That's in the first or fourth quadrant, tangent. And since it's positive, we're in the first quadrant. And the tangent, which is opposite over adjacent, 3/2. Well, that doesn't fit in the unit circle. That would be longer to make it be 3 and 2. So we can figure out the hypotenuse. It's 3 squared, which is 9, plus 2 squared, which is 4, and square root would be the hypotenuse. So that's a square root of 13. The cosine would be 2 over the square root of 13, which you could rationalize. And that's the first page. Second page. Determine the exact value of the cosine of negative 75. There's lots of combinations of angles that would make negative 75. Now, you can make negative 75 with negative 30 minus 45, or negative, negative 120 plus 45. Would that be, yeah, that would be negative 75. You could also do double that, would be negative 150 over 2. And on this one, if you did this one, the cosine of negative 30 minus 45, if I use the cosine formula for minus, then I would have a negative angle and a positive angle because I'm using the formula with the minus. So this would be the cosine of negative 30, cosine 45. If it's subtract, we add sine of negative 30, sine of 45. Cosine of negative 30 is the same as the cosine of 30, which is the square root of 3 over 2. Cosine of 45 is 1 over the square root of 2, plus sine of negative 30 is negative 1/2, and sine of 45 is 1 over the square root of 2. I could have also used square root of 2 over 2 and square root of 2 over 2. The way I have it right now would be square root of 3 minus 1, negative 1 times 1 is 1, over 2 square roots of 2. And I can't put those together, and so I can leave it like that. You would get the same answer if you did the cosine formula for this, but this would be add, so we'd have to put minus there. This was negative 120 plus 45. If you use the half angle formula, oh, and by the way, doing the cosine of negative 45, since the cosine is an even function, you can also use the fact that this would be just the cosine of 75. It would ignore the minus in there. And so you could have done 30 plus 45. Or you could have done 150 divided by 2. Now the cosine of an angle cut in half is plus or minus the square root of 1 plus the cosine of double the angle, 150, cosine of 150 over 2. If you use the negative, it'd be cosine of negative 150, but it won't matter. But we have to decide whether it's going to be positive or negative. Now, cosine of negative 75 is down here someplace. And so the cosines should be a positive answer. Now the cosine of 150 is clear over here, which is negative square root of 3 over 2. So it's 1 plus a negative square root of 3 over 2 divided by 2, all under the square root. And so I can write this also as 1/2 minus the square root of 3 over half of this is over 4. Those are a couple ways I could write the answer. So there are other ways. 5. The formula that the sum or difference formula that has cosine and sine is the cosine of, and if this is minus, a plus the two angles added, 72, 72, 28, 28. So this is going to be 72 plus 28, both degrees, which makes the cosine of 100 degrees. And that would be an exact value. If I went to decimal approximation, that wouldn't count. 6, it says show all of this equals minus cosine squared of x. And I saw lots of different ways of doing this. Some people said cotangent squared is cosine squared x over sine squared x. Excuse me. And cosecant is 1 over sine squared x. I'll just leave this one. Putting these together, I get cosine squared x minus 1 over sine squared x. But if we remember that sine squared x plus cosine squared x equals 1, then if we subtract 1 and subtract sine squared, we get negative sine squared x equals cosine squared x minus 1. So this is equal to negative sine squared. So this would be negative sine squared over sine squared, which is just negative 1. So we'd have negative 1 plus sine squared x. And then looking at this, negative 1 and moving the cosine squared over, this would be negative cosine squared, and it'd be negative 1 plus sine squared. So this is equal to negative cosine squared x. Some people said there's a rule about cotangent. If we divide everything by sine squared, we get 1 plus cotangent squared is equal to, and if I divide this by sine squared, is cosecant squared. So 1 plus cotangent squared is cosecant squared. So cosecant squared minus 1 is cotangent squared. So we could write the cotangent squared as cosecant squared x minus 1 minus cosecant squared x plus sine squared x. Cosecant squareds cancel. And I got sine squared minus 1, which I had right here, which is negative cosine squared x. That was a little bit simpler way to do it. You could also have thought that cotangent squared minus the cosecant squared would equal negative 1. So this would be is just negative 1, which we kind of showed here. Comes out to be negative 1. So it could have been an easy, we could have gone straight to this step if we use that rule and then gone to there. And there's other ways to do this one. Those are some of the ways I saw. This one, some people are not real good with their algebra skills here. You could write sine of 2 theta as 2 sine theta cosine theta, or you could write 2 sine theta cosine theta as sine 2 theta. So you could put this over sine 2 theta minus sine of 2 theta over sine of 2 theta, and that would be 1, and we could just simplify that. Let me do that. That'd be 2 cosine squared theta over 2 a sine 2 theta minus 2 a sine 2 theta over sine 2 theta. This is negative 1. And this would be 2 cosine squared theta over 2 sine theta cosine theta. One of the cosines cancel, the 2's cancel, and I get cosine over sine, which is cotangent theta minus 1. Others factored out a cosine in both of these, and the 2's had 2 cosine theta times cosine theta minus sine theta. And if we had that over the 2 sine theta cosine theta from the double angle formula, the cosines could cancel and the 2's could cancel, and then we'd have cosine theta minus sine theta over sine theta. Cosine theta over sine theta is cotangent theta. Minus sine theta over sine theta would be minus 1. Get the same answer another way. Okay, and now the next page says, what can you show this is equal to this? Well, the sine of 2 angles subtracted is sine of the first, cosine of the second, and the same subtraction or addition sign, subtract cosine of the first, sine of the second. And if we're putting this over the cosine alpha sine beta, if we put this under here, we get sine alpha over cosine alpha, which is tangent alpha, cosine over sine, which is cotangent beta, minus, and these two are the same, so when I put this under this part of the numerator, we get 1. And we're done. Number 9. The cosine, got to know what this is saying. This is saying 2 times the cosine of theta over 2 squared, so times the cosine of theta over 2. And the formula we have for the cosine of theta over 2 is plus or minus 1 plus the cosine of theta over 2. The whole thing's under the square root. So if we're going to take it times itself, it's like squaring it times a 2. And when I square this, I a plus squared is plus, a negative squared is plus, and so that's going to be plus inside, and a square root squared is square root's gone, and I get 1 plus cosine theta over 2 times 2, and the 2's cancel, and I get 1 plus cosine theta. Okay. Number 10. If the cosine, this says in the between 0 and pi, which is first and second quadrant, and the cosine is negative, so it's got to be over here in the second quadrant. So if I use sine squared theta plus cosine squared theta equals 1, I'd have sine squared theta plus 4/5 squared is 16/25 equals 1. If I subtract 16/25 from both sides, and 1 is 25/25, I'm going to get the sine squared theta equals 9/25. So the sine of theta equals plus or minus 3/5. Square root of 9 is 3. Square root of 25 is 5. And if I have to be in this quadrant, the sign is positive. So I'm going to forget the negative one and say this is going to be positive 3/5. Now, cosine beta, the sign is positive, and we're in the it's somewhere between negative pi over 2 and pi over 2, which is in the first and fourth quadrants. And sine is positive, and it's pretty big, so it's got to be up something like this. So the cosine is also going to be positive because that forces us to be in the first quadrant. And I'll use sine squared plus cosine squared equals 1, and the sine squared would be 144 over 169 plus cosine squared beta equals 1. So I'm going to take 144 over 169 away from 169 over 169. And cosine squared beta is going to be 25 over 169. And I take the square root, and cosine beta will be either plus or minus 5/13. But since we're in this quadrant, we're going to use the positive 5/13. Okay, the formula for sine of 2 theta, I didn't show all that, sorry. There it is. Sine of 2 theta is 2 sine theta cosine theta. And so I have 2. Now this says the sine of some angle is some number. And up here we found out the sine of theta is 3/5. So don't write sine again. We're taking the sine of the angle and getting the y-coordinate of 3/5. And the cosine, the x-coordinate on the angle, is negative 4/5. So we get 2 times 3, 6 times 4 is negative 24 over 5 times 5 times 1, 25. And there's our answer. Now we're supposed to do cosine of theta over 2. So that would be, the formula for that is plus or minus the square root of 1 plus cosine of just theta over 2. And the square root covers the 2 also. Now, which do we use, plus or minus? Well, theta was in the second quadrant. Now, if we take a half of The smallest angle in the second quadrant is 90. Half of it would be 45. And the largest angle in the second quadrant is 180. Half of it would be 90. So we'd be somewhere in here for theta over 2, which is what we're working with. And so it's going to be in the first quadrant, so it's got to be positive. So we're using this because we're in the first quadrant. Theta over 2 is. Okay, and we already know that the cosine is negative 4/5. So we're going to have square root of 1 plus a negative 4/5 over 2. And 1 is 5/5 minus 4/5 is 1/5 divided by 2, which is the square root of 1/10. Cosecant is the reciprocal of sine. So 1 over the sine of theta minus beta would be 1 over, and the sine formula for two angles subtracted is the sine of the first, cosine of the second, same operation. If it's minus here, it's minus 1 in the sine formula. Cosine, they change, but sine doesn't. And then it's sine cosine, then cosine of the first, sine of the second. So now we just have to look at that other page again and see what they are. So we have 1 over sine of theta is 3/5. Notice I'm not writing sine. The sine of the angle has a y-coordinate of 3/5. Cosine of beta up here was, down here was 5/13. And then we have minus. And the cosine of theta is negative 4/5. And the sine of beta was 12/13. And the minus minus will be plus. So we're going to have 1 over 15 over 5 times 13 is 65 plus 48 over 65, which is 1 over 53, 63 over 65, which is 65 over 63. Okay, next one. Find all the solutions to this. Okay, well, this is not a special angle. That's 4/5, but it's not special. So we will pull out the calculator. We can do this in degrees or radians. Turn it on, and I'm going to go cosine inverse of both sides. Check my mode. I'm going to change it to radians because I want these last problems in radians. So I'm just going to do radians right now of 0.8. So this is saying, what is the angle where the cosine is 0.8? Cosine of some angle is 0.8. So that 1 radian angle is 0.64. Now, just for your information, mode, if I go to degree and then press enter, that's about 36 degrees, 37 degrees. But okay, so I'm going to go back to radians. Okay, now, where's the cosine positive 0.8? 0.8's out here, so it would be some positive angle, but there's also a negative angle. And so we are, as I said in class, for these, if we do the set whose elements are angles such that the angle has to be 0.64 or negative 0.64. So we just do plus or minus on cosine, plus multiples of this place, plus 2 pi, or minus 2 pi, minus 2 pi, in this place also. So the plus and minus, both of them are times, are plus a multiple of 2 pi, where m is an element of the integers. And that's it. You could do it in degrees. Then this would be in degrees, 360, and this would be that 36.9 degrees. Now we got to know where the cosecant is 7. Well, the cosecant is the reciprocal of the sine, so the sine of some angle has got to be 1/7. And then we take the sine inverse both sides, and we get x has to be the sine inverse of 1/7. Now sine is a little bit harder. Second sine of 1 divided by 7, and I'm in radians, so I get an answer. This is positive, so I'm getting an answer in the first quadrant, small radian value, where the sine is 1/7. Okay, the other place where the sine is a positive 1/7 is over here. So it's giving me this angle of 0.143. This angle is the same size, but to get this angle, I have to take pi minus this. So I'm going to go pi minus my answer. And the other place is 2.998, which basically is 3. So I got two answers here. X, such that x can be 0.14143 plus multiples of 2 pi, or x can equal 3.00 plus multiples of 2 pi, where m is an element of the integers. Now we're on the last two. Now we just got to get the exact solutions between 0 and 2 pi. You cannot divide the 2 out of here. We could use the double angle formula to try to get in single angles, but that gets messy. What we want to do is get the tangent off here. So we're looking for where 2x is equal to the tangent inverse of -1. But we want all places. Now where's the tangent -1? That's here and there. And capital tangent would tell us to get from here in the second fourth, which would be -pi/4. But we can go just to here and then say multiples of pi. So 2x is 3 pi/4 plus multiples of pi. There and there and there and there. Or we can subtract and get -pi/4 and subtract and get more negative. But we only want the answers between 0 and 2 pi. So I'm going to divide this all by 2 and say x has to be, half of that is 3 pi/8 plus multiples of pi/2. I have to divide both of these by 2. Now, pi/2 is 4 pi, it's 4/8. 4/8 is 1/2. So 3 pi/2 is between 0 and 2 pi. 3 pi/8. If I add 4/8 to this, I'd get 7 pi/8. If I add 4 more, I'd have 11 pi/8. And I still haven't reached 2 pi, which would be 16. If I add 4 more, I'd have 15 pi/8. If I added any more, I would go over 16 pi over 8. And so there are the 4 answers to this one. Now this one. This one is starting to look like a quadratic. It looks sort of like 6 z squared equals 1 plus z. And anytime you have a quadratic, you get it equal to 0. So I'll subtract 1 and I'll subtract a z. So I got 6z squared minus z minus 1 equals 0. And I can use the quadratic formula, or I can factor probably 3z and 2z. And this would have to be 1 and 1, and one of these is negative. And the first times the first makes this. The last times the last is supposed to make that, so one of these got to be negative. And the outsides, 3z, and the 2z have to make the negative 1z. So if I make it negative 3z's plus 2z's, I get negative 1. So I set these equal to 0, and I get 3, and z stood for the cosine. Cosine theta plus 1 equals 0, or 2 cosine theta minus 1 equals 0. I solve this. Add 1, divide by 2, and I get the cosine of theta equals 1/2. Here I get the cosine of theta equals minus 1 divided by 3, minus 1/3. Okay, now these are cosines, and when you're doing cosine, it's just plus or minus whatever the calculator gives you. But I want exact, so I have to think about this. I know the exact for cosine, where cosine's 1/2. Cosine's 1/2 at pi over 3. And down here, that would be negative pi over 3, because we do plus or minus. But we want it between 0 and 2 pi, so we do the pi over 3, and then 2, 3, 4, 5 pi over 3. So there's 2 answers. Pi over 3 and 5 pi over 3. And these are both between 0 and 2 pi. Now I got to get where it's negative 1/3. Now cosine's negative 1/3, probably about there, which means there's an angle up there and one down there. Now, 1/3 is not a special, so I can't get an exact answer. If you went to decimal, I gave you credit if you took the calculator and did that. But we can just say it's cosine inverse of negative 1/3. That is an exact answer, and that would give me this one. Now to get this one, if I went this way, I'd get there, but I want to get this angle that's between 0 and 2 pi. So I'd have to go 2 pi minus this. So the last one in here would be 2 pi minus cosine inverse of negative 1/3. And that's how you could type it into the calculator to get that. So these are the 4 exact answers. And that's it.